Good afternoon, ma'am. I am going to show how to connect this hardware to the various ports. Now I have this power supply. This is a 15 volt power supply coming from this adapter. This is the blue light that's on. So I connected. This is the on-off switch. This is the 15 volt power supply. This is the USB cable, and this is for the laser trig. So I connect the power supply. Then I connect the USB cable. Then I also connect the laser trig. Now coming to the probe. So this is a 3 megahertz probe. This is the front side of the machine. I connect it with this orientation. Now it should be in the 6 o'clock, 12 o'clock position. I plug it in and make it 3 o'clock, 9 o'clock. Now it's switched on. Now this probe is connected securely. I'll switch it on. The red light glows. So there are two folders. One is for the raw data. One is for the B mode. The other is for the raw data. So I'll go to the B mode folder. Click on this. I applied gel and I'll do an imaging. Okay, so this is the B mode image. This is the gain. You can increase the gain. This is the depth now. And I can freeze it. Then review through the image. So that's all with the B mode. Now I want to change to the next probe. What I do is go to this combo box and select the 10 megahertz probe. The software needs to close. We'll say yes, and I'll switch it off. Remove this probe. And I'll connect the linear probe. 10 megahertz probe. I connected it. Switch it on. So this is showing 10 megahertz probe. And this is the penetration of. I need to now, in order to go to the raw image, I switch this off. Go to the other folder which shows k32p raw. Open it, and I'll have to click it. For that, I'll switch this hardware on, and So this screen, this is the A mode image of a single channel. We can scroll through the different channels. Shade signal here. Go through this. Click the raw start. I have acquired it. Now I'll scroll through the various channels. Now I'll say dump AFM data. It has dumped all the data to a file. This is the file it has dumped to, bafmdump.raw. This is a binary file having all the data for 8 frames into 32 channels into 8K points for each channel. This can be, I'm presently using this Excel tool to visualize the data. So what it does is, it has a macro running. In a moment we will go through the macro, and it takes the data and plots it in each of the cells, and then we view it through this simple graph. So we will go through let me show you the simple Alt F11 macro which shows it. This is the macro for so much K points for each channel. Just plot it into the cell. It reads the data and plots it, and from here we are seeing it. This can be this raw file can be directly into MATLAB using Java code or Python, whatever it is. Next one will be to acquire the photoacoustic signal. So similarly I switch on. Go through the same raw data acquisition. This is scan. Now I'll freeze it. Once I freeze it, I get this button, photoacoustic imaging button. Click on this, we get this screen. And now I'll say acquire. So it's waiting for the photoacoustic laser trick to come in. If there is no trick, it just says timeout. So once again I'll click acquire and give a signal generator pulse. And what I am giving is through this pulse generator feeding into the laser trick, I am giving a 3.3 volt pulse high and the low level is 0 volt. 1 microsecond white pulse I am giving. So let me switch on the pulse and okay, I'll switch it off. I'll say acquire, and whenever the pulse comes within the specific time, it gathers a signal. So this is a signal. Same way we can scroll through the channels. And this is the entire 8K signal from 5 to 209 microseconds. This is the signal. Now I can do the same dump data. This has been dumped to a dump.raw file. Now again using the same tool I can view it. Okay, so this is the data 4 to -4, almost no signal from channel 0 to 32 channels. So if there was a laser excitation, we would get a nice waveform here. So that's it. We have covered all the features.